Hi, welcome to this Corbettmaths video. In this video, we're going to go through the video solutions to the Corbettmaths practice questions on Surds. If you need any extra help on Surds, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 305, 306, 307, 308, there's dedicated video tutorials there on Surds and different aspects of Surds. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so let's have a look at question number 1. So question number 1 starts off with part A. Evaluate the following, and we've got root 3 multiplied by root 7. So to simplify root 3 multiplied by root 7, what we're going to do is we're going to times the numbers together. And 3 times 7 is 21. So root 3 times root 7 would be the square root of 21, or root 21. So the answer is root 21. Okay, let's look at our next part, part B. So part B, we've been asked to simplify the square root of 24 divided by the square root of 6. So to do this, let's divide the numbers, because remember, root A divided by root B is root A over B. So if we just divide the 24 by 6, that'll tell us what goes underneath the square root sign. So let's work that out. 24 divided by 6 is equal to 4. So root 24 divided by root 6 would be equal to root 4. Now 4 is a square number, so we can actually square root that. The square root of 4 is 2, so the answer would just be 2. So root 24 divided by root 6 is equal to 2. So that's the answer, 2. Okay, let's look at our next part, part C. So part C, we've been asked to simplify 2 root 3 multiplied by 3 root 5. So what we're going to do is we're going to multiply the numbers in front of the surds to begin with. So 2 times 3 is equal to 6. And then we're going to put our square root symbol, and then we're going to do 3 times 5. And 3 times 5 is 15. So that means that 2 root 3 multiplied by 3 root 5 will be equal to 6 root 15. So that's the answer, 6 root 15. And that's it. Okay, let's look at part D. Okay, so part D, we've been asked to simplify 10 root 8 divided by 2 root 2. So what we're going to do is we're going to divide the numbers in front of the surds to begin with. So 10 divided by 2 is equal to 5. Then we're going to put our square root symbol, and then 8 divided by 2 is equal to 4. So the number underneath the root symbol will be 4, just doing 8 divided by 2. So we've got 5 root 4. Now the square root of 4 is 2, so it's going to be, instead of 5 times root 4, it's going to be 5 times 2. And 5 times 2 is equal to 10, so the answer would be 10. And let's just recap that. 10 divided by 2 is equal to 5. Root 8 divided by root 2 is equal to root 4. The square root of 4 is 2, so we've got 5 lots of 2, and 5 lots of 2 is equal to 10. So the answer would be 10. Okay, let's look at our next question, question number 2. So question number 2, we've been asked to simplify the square root of 3 squared. So this question is a few different ways you could approach it. One approach is to just think, well, if we're square rooting something and then we're squaring, we're just going to be left with what that something was. So the answer would just be 3, because to square root and then to square, the inverse operation, so you end up with what you started with. So the answer would just be 3. So that's one way to approach it. The other way to approach it is, well, if we're squaring something, we're multiplying it by itself. So we've got root 3 squared, so it's going to be root 3 multiplied by root 3. The square root of 3 times the square root of 3, well, 3 times 3 is equal to 9, so it'd be the square root of 9. And the square root of 9 is 3, so the answer would just be 3. And that's it. Okay, let's look at our next question, question number 3. Okay, so question number 3, we've been asked to work out the exact value of the square root of 2 all to the power of 4. So what I'm going to do is, if we've got something to the power of 4, it means we're going to have 4 lots of it times together. So it's going to be the square root of 2 multiplied by the square root of 2 multiplied by the square root of 2 multiplied by the square root of 2. So to work out what's going to go underneath the square root symbol, we're just going to do 2 times 2 times 2 times 2. 2 times 2 is equal to 4, times 2 is equal to 8, times 2 is equal to 16. So we've got the square root of 16, and the square root of 16 is 4. So the answer would just be 4. So the square root of 2 all to the power of 4 will be equal to 4. And that's it, so that's our answer, 4. Okay, let's look at our next question, question number 4. Okay, so question number 4, we're going to be simplifying some surds here. So 4a says express the square root of 75 in its simplest form. If you type in the square root of 75 into your calculator and press equals, it won't come up with the square root of 75, it'll come up with 5 root 3. And let's see why. So if we want to simplify a surd, what we do is we look at the number 75 and we look for the biggest square number that's a factor of 75. So the biggest square number that's a factor of 75 would be 25, because 3 times 25 is equal to 75. So 25 goes into 75 3 times. So what we're going to do is we're going to split this surd up. So we're going to split it up into the square root of 25 multiplied by the square root of 3. So to find this number, we just think, what's the biggest square number that's a factor of that number? So that's 25, so we've got the square root of 25, and then we'd write down the square root of 3, because 3 times 25 is equal to 75. So we're just splitting up the surd. So where we had earlier, root a times root b is equal to root ab, here we're taking the root ab and splitting it up into root a times root b. So we're just splitting it up, where one of the numbers is a square number. Okay, so the square root of 25 is 5. So instead of writing root 25, I'm just going to write 5. And then we've got times the square root of 3. And then we're just going to put these together. 5 times the square root of 3 would just be 5 root 3, 5 lots of root 3. And that's it. So that means if we wanted to simplify the square root of 75, the answer would be 5 root 3. Okay, let's look at the next one, part B. So part B says express the square root of 32 in its simplest form. So we need to simplify this surd. So let's find the biggest square number that's a factor of 32, and I'm thinking 16, because 16 plus 16 is 32. So we're going to write the square root of 16 multiplied by the square root of 2. And the reason we've chosen those numbers are, that's the biggest square number, that's a factor of 32, and then it would have to be times 2, because 16 times 2 is 32. The square root of 16 is 4, so we've got 4 times root 2, so 4 lots of root 2. And 4 lots of root 2 would be 4 root 2. So the answer is 4 root 2. And that's it. That's our answer. Okay, let's look at our next part, part C. So part C, we've been asked to express root 8 in its simplest form. So we've been asked to simplify root 8. So the biggest square number that's a factor of 8 would be 4. So that would be root 4 multiplied by. And to get 8, we'd have to do 4 times 2, so it's going to be root 2. So 4 is the biggest square number that's a factor of 8, and then 4 times 2 is equal to 8, so that's why we put the 2 there. The square root of 4 is 2, so that would be 2 lots of root 2. So the answer would be 2 root 2. We just put them together, so it's 2 root 2. Okay, let's look at one more, part D. And what I would say is, with simplifying these surds, the more you do, you actually get really good at it, and you can do it really quickly. So we've been asked to simplify the square root of 200. So 100 is a factor of 200, and that's the biggest square number that's a factor of 200, which would be 100. So we're going to write the square root of 100 multiplied by the square root of 2. And 100 times 2 is equal to 200. The square root of 100 is 10, so we've got 10 times root 2, or 10 lots of root 2. So the answer is just 10 root 2. And that's it. That's our answer. Okay, let's look at our next question, question number 5. Okay, so question number 5, we've been asked to simplify the square root of 5 multiplied by the square root of 10, or root 5 times root 10. So here we've got root a times root b, so we just times those numbers together. 5 times 10 is equal to 50, so we've got the square root of 50. And the square root of 50, well, 25 is the biggest square number that's a factor of 50, so we're going to write down the square root of 25 multiplied by the square root of 2, just simplifying this square root of 50. And the square root of 25 is 5, so we've got 5 times root 2, which would just be 5 root 2. And that's it. So we've done root 5 times root 10, which is root 50. And then we simplified this surd, just thinking, what's the biggest square number that's a factor of 50? That's 25, so we've got root 25 times root 2. The square root of 25 is 5, so we've got 5 lots of root 2, so the answer is 5 root 2. And that's it. Okay, let's look at our next question, question number 6. So question number 6 says, simplify fully root 50 plus root 32. So when we're adding surds, what we're going to do is we're going to simplify each of them. Hopefully they'll both be so many lots of the same root. So for instance, this one may be 5 lots of root 2. This one perhaps may be 4 lots of root 2, and then we could add them together to give us so many lots of root 2. Well, let's have a look at this question. So we've got root 50. So let's simplify root 50 here. So root 50. Now the biggest square number that's a factor of 50 is 25. So that would be root 25 multiplied by, well, to get 50, it'd be 25 times 2, so root 2. The square root of 25 is equal to 5, so that'd be 5 root 2. So here, where we've got root 50, I'm going to write 5 root 2, because root 50 is 5 lots of root 2. Now, let's simplify root 32. So root 32. So the biggest square number that's a factor of 32 is 16, so that'll be root 16 multiplied by root 2. The square root of 16 is 4, so that'll be 4 times root 2, or 4 root 2, 4 lots of root 2. So root 32 is 4 lots of root 2. So instead of root 50 plus root 32, we've now got 5 lots of root 2 plus 4 lots of root 2. And 5 lots of root 2 plus 4 lots of root 2 would be 9 lots of root 2, so 9 root 2. Just adding the numbers in front of the surds. So that's it, so 9 root 2, and that's it. So part B, we've been asked to simplify root 80 plus root 20. So again, we're going to simplify each of these surds and then see what we get. So root 80. The biggest square number that's a factor of 80 is 16, because 5 times 16 is equal to 80. So that'd be root 16 multiplied by root 5. And the more Surds questions you do, you get to learn these off by heart. So I know that root 80 is equal to 4 root 5 off by heart, but as you do more of these questions, you'll get really good at that. So we've got root 80 is equal to root 16 times root 5, just splitting it up, and that's the biggest square number that's a factor of 80. And you could, if you wanted to, write the factors of 80 and see 16 is the biggest square number that's a factor of 80. The square root of 16 is equal to 4, so you get 4 root 5. So 80 is equal to 4 lots of root 5. Then we've got plus, and now let's simplify root 20. So root 20, so the biggest square number that's a factor of 20 is 4, so it'll be root 4 times root 5. And in these questions, you'll notice that those second surds should be the same, so you get so many lots of root 5 again. The square root of 4 is equal to 2, so it'll be 2 root 5. So the square root of 20 is equal to 2 lots of root 5. So we had root 80 plus root 20, that's equal to 4 root 5 plus 2 root 5, or 4 lots of root 5 plus 2 lots of root 5. And when you add those together, that's equal to 6 lots of root 5, so 6 root 5. And that's it. Okay, and let's look at our last part, part C. So part C, it's a subtraction rather than an addition, but we'll do it in the same approach. Root 200, so that's root 200. Well, root 200, if we simplify it, the biggest square number that's a factor of 200 would be 100. So we've got root 100 multiplied by root 2. The square root of 100 is 10, so we've got 10 root 2. So root 200 would be 10 lots of root 2. And then we've got subtract. And now let's cancel down root 72. So root 72, the biggest square number that's a factor of 72 would be 36. So 36, so the root 36 multiplied by root 2. So we've got root 36 times root 2. And then the square root of 36 is 6, so that's 6 root 2. So we had root 200 take away root 72. And root 200 is 10 lots of root 2. Root 72 is 6 lots of root 2. And 10 lots of root 2 take away 6 lots of root 2 would be 4 lots of root 2. And that's it, 4 root 2. And that's it. Okay, let's have a look at our next part, part D. So part D, this time we've got 3 root 12 plus root 75. Now this part's a little bit different than the other parts we've looked at so far, because rather than just being root 12 plus root 75, we've got 3 lots of root 12 plus root 75. So what I'm going to do is I'm going to simplify each of these surds just like before, but we need to be careful because whatever the root 12 is, we need to multiply that by 3 because it's 3 lots of root 12. So root 12, the biggest square number that's a factor of 12 is 4, so that'll be root 4 times root 3. The square root of 4 is 2, so that'll be 2 root 3. So here we had 3, and then instead of root 12, I'm going to put in brackets 2 root 3, so 2 root 3, because root 12 is 2 lots of root 3. And then plus, and let's cancel down root 75. So root 75, the biggest square number that's a factor of 75 is 25. So that's root 25 multiplied by root 3. The square root of 25 is 5, so that'll be 5 root 3. So root 75 is 5 lots of root 3, 5 root 3. And now we just need to work this out. Now here we had 3 times root 12, so that's 3 times 2 lots of root 3. Well, if we've got 2 lots of root 3 and we times it by 3, that'll be 6 lots of root 3. You're just multiplying the number in front of the surd. So 3 times 2 root 3 would be 6 root 3. And that makes sense because if you do 2 root 3 plus 2 root 3 plus 2 root 3, that'll be 6 root 3. And that's 3 lots of it. And then we've got add 5 root 3, 5 root 3. And 6 lots of root 3 plus 5 lots of root 3 would be 11 lots of root 3. So the answer is 11 root 3. And that's it. Okay, let's look at our next question, question number 7. Okay, so question number 7 says, Tilly's been asked to work out root 2 plus root 8. And Tilly says that the answer is root 10 because 2 plus 8 is equal to 10. Is Tilly correct? Explain your answer. Well, no, Tilly's not correct. Root A plus root B is not equal to root A plus B. So that's not going to work. Okay, so Tilly's not correct. And actually, let's actually work this out, because if we had root 2 plus root 8, we could actually perhaps work this out because this simplifies down. So actually, let's just explain that to begin with. I'm actually going to just explain that root A plus root B is not equal to root A plus B. So no, as root A plus root B does not equal the square root of A plus B. So that's not the case here. The square root of 2 plus the square root of 8 is not equal to the square root of 10. Now actually let's actually see if we can work out this question. Because the square root of 8, the square root of 8, well the biggest square number that's a factor of 8 would be 4, so that'll be root 4 times root 2. The square root of 4 is 2, so that's 2 root 2, so root 8 is 2 root 2, or 2 lots of root 2. So we would have root 2 plus, and instead of root 8, 2 lots of root 2. And root 2 plus another 2 lots of root 2, well that's 1 lot of root 2 plus 2 more lots of root 2 would be 3 lots of root 2. So the answer is 3 root 2. So Tilly's not correct because root 10 isn't 3 root 2. The answer is actually 3 root 2. And that's it. Okay, let's look at our next question, question number 8. So question number 8, we've been asked to express the square root of 2 plus the square root of 98 in the form of a root 2, where a is an integer. So this is a number that we need to work out. And actually what we're going to do is we're just going to add these surds together. Now root 2 is quite nice, that's already simplified. Root 2 is just root 2. But let's simplify root 98. So root 98. And again, if you're good at your square numbers, you can see that that's going to be, well, root 49 multiplied by root 2, because 49 is a factor of 98 and it's the biggest square number that's a factor of 98. So we've got root 49 times root 2. The square root of 49 is 7, so that's 7 root 2. So the square root of 98 would be 7 lots of root 2. So we've got root 2, which is 1 lot of root 2, plus 7 more lots of root 2. That'll be 8 lots of root 2. So that a is equal to 8, but we were asked to write it in that form, so the answer would be 8 root 2. And that's it. Okay, let's look at our next question, question number 9. Okay, so question number 9, we've been asked to write the square root of 150 plus the square root of 24 in the form of k root 6. So again, we just need to add together these surds, and when we do that, we should get so many lots of root 6. So root 150, well, let's find the biggest square number that's a factor of 150. So I'm going to write 150 here, the square root of 150 would be equal to, what I'm actually going to do is I'm going to consider the square numbers. So 150, well, 144, no. 121, no. 100, no. And I'm just working my way down through the square numbers here. 81, no. 64, no. 49, no. 36, no. 25, yes. If you count up in 25s, you get to 150. So it's going to be root 25 multiplied by, and actually this would have helped us because 6 is going to be the other number. So 6 times 25 is 150. So root 6. And the square root of 25 is 5, so that's 5 lots of root 6. So it means the root 150 is 5 lots of root 6. So root 150, I'm going to write 5 root 6 there, and then plus, and then we're going to simplify the root 24. So root 24 would be equal to, well, we know one of them is going to be root 6 because we know we're writing in the form of k root 6. So 6 times 4. So that means that 4 is the biggest square number that's a factor of 24. And the square root of 4 is 2, so that's 2 lots of root 6. So we've got 5 root 6 plus 2 root 6. And that's just found by simplifying these surds. If you simplify root 150, you get 5 root 6. And if you simplify root 24, you get 2 root 6. And if we've got 5 lots of root 6 and we add 2 lots of root 6, that's 7 lots of root 6. So that would be our answer, 7 lots of root 6. So that means that value of k was 7, but we wanted to write in that form, so it's 7 root 6. And that's it. Okay, let's look at our next question, question number 10. Okay, so question number 10 says, shown below is a rectangle. So we've got this rectangle, and the length of the rectangle is 5 root 2 centimeters, and the width of the rectangle is root 2 centimeters. And part A says, find the perimeter of the rectangle. So the perimeter is the distance around the outside. So here we've got 5 root 2 centimeters, so that means that this length would be 5 root 2 centimeters. On the right hand side, the width of the rectangle is root 2 centimeters, so the left hand side would also be root 2 centimeters. And we want to find the perimeter, the distance around the outside. So if we want to find the distance around the outside, we need to add these together. So we're going to do 5 lots of root 2. So I'm just going to go down here a little bit. 5 root 2 plus root 2 plus 5 root 2 plus root 2. So 5 lots of root 2 plus another lot of root 2 would be 6 lots of root 2, plus another 5 lots of root 2 would be 11 lots of root 2, plus another root 2 would be 12 lots of root 2, so 12 lots of root 2, or 12 root 2, and that's it. Okay, and then part B. Part B says find the area of the rectangle. So to find the area, we do the length multiplied by the width. So we're going to do the length, which is 5 root 2, multiplied by the width, which is root 2. And let's work that out. So to multiply these surds together, we multiply the numbers in front of the surds. So 5 times 1. So 5 times 1 is equal to 5. And then we've got root 2 times root 2. And root 2 times root 2 is equal to root 4, because 2 times 2 is equal to 4, so we've got root 4. And the square root of 4 is 2, so we've got 5 times 2. And 5 times 2 is equal to 10. So the answer would be 10. So our area of that rectangle is 10 centimeters squared. And that's it. And just to recap here, we've done the length multiplied by the width. So to multiply these numbers together, we multiply the numbers in front of the surds to begin with. So 5 times 1 is equal to 5. And then root 2 times root 2 is root 4. The square root of 4 is 2. And we've got 5 lots of 2, which is 10. And that's it. Okay, let's look at our next question, question number 11. Okay, so question number 11, we've been asked to write each of the following in the form of a root 3, where a is an integer. So let's work them out. Part A. So part A, we've got root 6 times root 8. So we've got root A times root B is equal to root AB. So we just need to multiply these numbers together. 6 times 8 is equal to 48. So that'll be root 48. And then we just need to simplify it. So the biggest square number that's a factor of 48, or 49, no, that's too big. 36, no. 25, no. 16, yes, 16 plus 16 plus 16 was 48. So it's going to be root 16 multiplied by root 3. And the square root of 16 is 4, so that'll be 4 root 3. So that's our answer, 4 root 3. Okay, and then part B. Part B, we've been asked to add root 27 plus root 75. Now, we've already looked at root 75 a few times already. That's going to be 5 root 3, but let's do it anyway. The square root of 75 will be equal to, well, considering the square numbers, well, the biggest square number is a factor of 75. Well, let's work our way down. 64, no. 49, no. 36, no. 25, yes. That's root 25 times root 3. The square root of 25 is 5, so it'll be 5 root 3. So the square root of 75 is 5 lots of root 3 plus. And then we've got root 27, so let's simplify that. So root 27. So the biggest square number is a factor of 27. Now you can actually use the answer to help us. We know it's going to have to be in the form of a root 3. So it's going to have to be times root 3 there. And that means that that would have to be root 9. Or you can just figure out that 9 is the biggest square number that's a factor of 27. And the square root of 9 is 3, so that's 3 root 3. So root 27 is 3 root 3. So we've got root 27, which is 3 root 3, plus root 75, which is 5 root 3. And if we add those together, 3 lots of root 3 plus 5 lots of root 3 is 8 lots of root 3, so 8 root 3. And that's our answer, 8 lots of root 3. Okay, let's look at our next question, question number 12. Okay, so question number 12, it's a rationalising the denominator question. So whenever we've got a surd in the denominator, we don't like it, we want to get rid of the surd on the denominator, so we rationalise the denominator. Root 5 is irrational, so we want to make it rational. And to do that, what we're going to do is we're going to multiply both the numerator and the denominator by this surd. So we're going to multiply both the numerator of the fraction by root 5 and the denominator by root 5. And let's see what we get. Well, 15 times root 5 will be 15 lots of root 5, so that's 15 root 5, just multiplying the numerator by root 5. And then the denominator, we've got root 5 times root 5. Now, root 5 times root 5 would be 5, because root a times root a is equal to a. Or another way to think of it, if you want to, is root 5 times root 5 is root 25, which is also 5. So we've got that if we have 15 over root 5, that's the same as 15 lots of root 5 over 5. So that's, as you can see here, the denominator has been rationalised. It's now a rational number, not irrational. Now here, you've got 15 lots of root 5 divided by 5. Well, 15 lots of root 5, if you divide it by 5, you'll get 3 lots of root 5. So we can divide that number by 5. And 15 divided by 5 is 3. So that would be 3 lots of root 5. And because the 15 was divisible by 5, we could just do 15 divided by 5, and that's 3. So it's 3 lots of root 5. So 3 root 5. And that's it. So the answer is 3 root 5. And that's it. We've rationalised the denominator. The denominator is technically 1 now, so that's rationalised. Okay, let's look at our next question, question number 13. So question number 13, we've been asked to simplify fully root 600 plus root 24. So root 600, I'm thinking 100 will be the highest square number, the greatest square number, the biggest square number. It's a factor of 600. So we're going to go for root 100 multiplied by root 6, because that's what the square root of 600 would be, root 100 times root 6, and that would be 10 root 6 if we cancel it down. And root 24 would be root 4 times root 6, because the biggest square number that's a factor of 24 is 4. And then the square root of 4 is 2, so that's 2 root 6. So root 600 is 10 lots of root 6, and root 24 is 2 lots of root 6. And we've been asked to add them together, so 10 lots of root 6 plus 2 lots of root 6 is equal to 12 lots of root 6. So the answer is 12 root 6. And that's it. Okay, let's look at our next question, question number 14. So question number 14a says, rationalise the denominator of 12 over root 3. So as you can see here, the denominator is irrational, it's a surd. So let's rationalise it. So let's multiply both the numerator and denominator of the fraction by root 3. So 12 times root 3 is 12 root 3. And on the denominator, root 3 times root 3 is equal to 3. So we've got 12 root 3 over 3. Now 12 is divisible by 3. If you've got 12 lots of root 3 and you divide it by 3, you're going to get 4 lots of root 3. So the answer would be 4 root 3, just dividing the 12 by 3. So if you get 12 lots of root 3 and you divide it by 3, you get 4 lots of root 3. And as you can see here, that would be over 1. So we've rationalised the denominator. So it's 4 root 3. Okay, and then part B. Part B says to evaluate root 2 times root 32. So this is root A times root B, so that'll be root AB. We just need to multiply the numbers beneath the square root symbol. And 2 times 32 is equal to 64, so we get root 64. Now 64 is a square number. The square root of 64 is 8, so the answer would just be 8, and that's it. Okay, let's look at our next part, part C. So in part C, we've been asked to expand and simplify root 3 plus root 5 all squared. Now I really like these questions because you've got brackets and surds and you get to expand the brackets with surds, and I really like it. So we're squaring it, so it means we're multiplying by itself. So we've got root 3 plus root 5, and then in brackets root 3 plus root 5. And now we just need to expand these. So root 3 times root 3 would be equal to root 9, or I just go for 3, so 3. And then root 3 times root 5 would be root 15, so plus root 15. Root 5 times root 3 would be another root 15. And then finally, root 5 times root 5 would be root 25, or just 5, so 5. And then we can simplify this. 3 plus 5 is equal to 8, so we've got 8. And then root 15 plus root 15 would be 2 lots of root 15, so plus 2 root 15. So the answer would be 8 plus 2 root 15. And that's it. We've expanded and we've simplified. Okay, now part D. So we've been asked to evaluate 5 plus root 2 in brackets multiplied by 5 minus root 2 in brackets. So let's expand these. So 5 times 5 is 25. 5 times minus root 2 would be minus 5 lots of root 2. Root 2 times 5 would be plus 5 lots of root 2, because you're doing root 2 times 5, so it'd be plus 5 lots of root 2. And then finally, you've got root 2 times minus root 2. So root 2 times root 2 is 2. Now you've got a positive times a negative, so it will be minus 2. So let's just check those again. 5 times 5 is 25. 5 times minus root 2 would be minus 5 lots of root 2. Root 2 times 5 would be 5 lots of root 2. And finally, root 2 times minus root 2. Well, root 2 times root 2 is equal to 2, and a positive times a negative is a negative, so it's going to be minus 2. And now let's simplify this, because you've got 25 take away 2, that's 23. And then you've got minus 5 lots of root 2 plus 5 lots of root 2. Well, they add together to be 0, so you're just left with 23. So the answer is just 23, and that's it. Okay, let's look at our next question, question number 15. Okay, so question 15a says simplify fully root 3 and then in brackets root 27 minus root 3. So let's expand the brackets here. Root 3 times root 27. Well, 3 times 27 is 81, so it's the square root of 81. And then we've got minus, and then root 3 times root 3 would be root 9, or you could just go for 3, because root 3 times root 3 would just be 3. So you've got root 81 minus 3. The square root of 81 is 9, so you get 9 minus 3, and 9 minus 3 is equal to 6. And that's it, the answer is just 6. And that's it. So root 3 times root 27 is root 81, which is 9. And root 3 times root 3 is equal to root 9, or 3. The square root of 9 is 3. And then you end up with 9 minus 3, which is 6. And that's it. Okay, let's look at part B. Okay, part B says, given that A is equal to root 2, and B is equal to root 15, and C is equal to root 30, we've been asked to work out the value of B over AC. Okay, so B, that's root 15, so you've got root 15 on the numerator, and then over, and then on the denominator you've got AC, so it's going to be root 2 times root 30, so root 2 times root 30. So we've just substituted in the surds for each of the letters, and with AC it means A times C, so we've got root 2 times root 30. Now we need to simplify this, so let's simplify it. Let's start off with the denominator. Root 2 times root 30. Well, times the two numbers together would be root 60. So root 15 over root 60. Okay, now we've been asked to give our answer in its simplest form. So we've got root 15 over root 60. But let's try and cancel this down. So root 15, well, that doesn't actually cancel down, so let's keep the numerator as root 15. And with the denominator, we've got root 60, so let's cancel down root 60. Root 60, well, the biggest square number that's a factor of 60 would be 4, so that'd be equal to root 4 times root 15. And the square root of 4 is equal to 2, so that's 2 lots of root 15. So root 60 is 2 root 15. So the denominator will be 2 root 15. So we've got, let's actually have a look at this, we have got on the numerator, root 15. On the denominator, 2 lots of root 15. So let's divide both the numerator and the denominator by root 15. So root 15 divided by root 15 would be 1, and 2 lots of root 15 divided by root 15 would just be 2. So the answer would be a half. And that's it. That's our answer in its simplest form. Okay, let's look at our next question, question number 16. Okay, so question number 16, we've been asked to rationalise the denominator of 12 over 7 root 3. So here, as you can see, the denominator is irrational because you've got the surd on the denominator. So let's get rid of the surd by multiplying both the numerator and the denominator by root 3. So let's multiply the numerator by root 3 and the denominator by root 3. So the numerator, if you've got 12 and you times it by root 3, that'll be 12 lots of root 3. The denominator, we have 7 lots of root 3. We're timesing it by root 3. Now, root 3 times root 3 is equal to root 9, or the square root of 9 is 3. And remember that root a times root a is equal to a. So root 3 times root 3 is equal to 3. So we've got 7 times 3. So 7 times 3. And again, I've just done root 3 times root 3 is equal to 3, and we've still got the multiply by 7 in front of it. I'm just going to do 7 times 3 here on the denominator. So on the numerator, we've got 12 lots of root 3, and on the denominator, we've got 7 times 3, which is 21. Now here, if we have a look here, we've got 12 lots of root 3 over 21. We have rationalised the denominator. It's a rational number, 21. But I'm actually going to try and cancel this down because 12 and 21 are both divisible by 3. They're both in the 3 times tables. So let's divide both the numerator and the denominator by 3. 12 lots of root 3 divided by 3 would be 4 lots of root 3. And on the denominator, we had 21. Dividing it by 3 would be 7. So the answer would be 4 root 3 over 7. And we've just cancelled it down. And 4 7s can't be cancelled down any further. Now this part here, you could just cancel down the 12 over 21 separately. Cancel that down and you get that's equal to 4 7s. But I just cancelled it down like that. I've got that's equal to 4 root 3 over 7. And that's it. Okay, let's look at our next question, question number 17. So question number 17, we're given that a is equal to root 3 and b is equal to root 48. And we've been asked to work out the value of a squared. So a squared will be root 3 squared. So root 3, that's a squared. And root 3 squared, well, that'd be root 3 times root 3, which is just 3, or root 3 times root 3 is root 9, which is 3. So that's it, the answer would just be 3. And then part B says, show that a plus b, all squared, is equal to 75. Okay, so let's substitute in our values. So we have got a, that's root 3, and then plus b, which is root 48, and then close bracket squared. And we've been asked to show that that's equal to 75. So let's work this out and see, do we get 75? So squared means multiply by itself, so that would be root 3 plus root 48 multiplied by root 3 plus root 48, just writing the bracket out twice. So we've got root 3 times root 3, that's equal to 3. Then we've got root 3 times root 48. Well, let's work out what that would be. So root 3 multiplied by root 48. So 3 times 48, well, let's work out what that is. So we've got 48 times 3. 3 times 8 is equal to 24. Put the 4 down, carry the 2. 3 times 4 is equal to 12, plus 2 is equal to 14. I'm just laughing because that's equal to the square root of 144. And if you square root 144, that's equal to 12. So root 3 times root 3 is equal to 3. Root 3 times root 48 is equal to root 144, which is 12, so plus 12. Root 48 times root 3 is also equal to root 144, which is plus 12. And then finally, root 48 times root 48 would be 48. So we've got 3 plus 12 plus 12 plus 48. Now 48 plus 12 is equal to 60, plus 12 is equal to 72, plus 3 is equal to 75, so 75. So that's it, we've shown it. We've shown that a plus b all squared is equal to 75. whenever a is equal to root 3 and b is equal to root 48. Okay, let's look at the next question, question number 18. So question number 18, we've been asked to expand and simplify 3 plus root 8 multiplied by 4 plus root 2. We've been asked to give our answer in the form a plus b root 2, where a and b are integers. Okay, so let's work this out. So we've got two brackets, let's expand them. 3 times 4 is equal to 12. 3 times root 2 would be equal to plus 3 root 2, 3 lots of root 2. Root 8 times 4 would be 4 lots of root 8, so plus 4 lots of root 8. And then finally, root 8 times root 2 would be plus root 16, because 8 times 2 is equal to 16, so it would be root 16. Now let's simplify this, because we've been asked to give our answer in the form of a plus b root 2. Here we've got a root 8, so that means we can simplify that. Root 16 is actually equal to 4, so let's simplify this. So we've got 12 plus 3 root 2, we can't simplify those, plus 4 root 8. Well, root 8 will be equal to root 4 multiplied by root 2, because 4 is the biggest square number that goes into 8. So we've got root 4 times root 2, so that'd be 2 root 2. So root 8 is 2 root 2, but this is 4 lots of root 8, so that's 4 lots of 2 root 2. And 4 lots of 2 root 2, well, 4 times 2 is equal to 8 lots of root 2, so 8 lots of root 2. So root 8 is 2 lots of root 2, and then if we have 4 lots of that, that'll be 8 lots of root 2. And then plus, and the square root of 16 is 4. Now this is fantastic, because everything we've got here is either an integer or something with root 2's in it. So 12 plus 4 is equal to 16, and then plus, and then we've got 3 lots of root 2 plus 8 lots of root 2, that'll be 11 lots of root 2. So the answer is 16 plus 11 lots of root 2, and that's it. Okay, let's look at our next question, question number 19. So question number 19, we've been asked to simplify 5 root 8 plus root 18. So let's simplify this. So actually what we're going to do is we're going to simplify the surds to begin with, because root 8 I know we can simplify. Think back to our last question. And root 18 can be simplified as well, so that'll help us with this addition. So let's start off with the root 18. So root 18 would be equal to, well, the biggest square number that's a factor of 18 is 9, so root 9 times root 2, and the square root of 9 is 3, so 3 root 2, 3 lots of root 2. So root 18 is 3 lots of root 2. Root 8, well, that's equal to, the biggest square number that's a factor of 8 would be 4, so that'll be root 4 times root 2, and the square root of 4 is 2, so that'll be 2 lots of root 2. So root 8 is 2 lots of root 2. Now here we've got 5 lots of root 8, so here we've got 5 lots off, and then I'm just going to put in brackets what root 8 is, which is 2 root 2, so 2 lots of root 2, plus, and then root 18 is 3 lots of root 2. So here we've got 5 times 2 lots of root 2. Well, if you've got 5 lots of 2 lots of root 2, well, that'll be 10 lots of root 2, 10 lots of root 2. And thinking about it, 5 times 2 is equal to 10, so that'll be 10 lots of root 2. And then plus 3 lots of root 2. And 10 lots of root 2 plus 3 lots of root 2 will be equal to 13 lots of root 2, so 13 root 2. So that's our answer, 13 root 2. Okay, let's look at our next question, question number 20. So question number 20, we've been asked to rationalise the denominator of 8 over root 2. So as you can see, the denominator is irrational, it's a surd, so let's multiply both the numerator and the denominator by root 2. So the numerator, 8 times root 2, would be 8 lots of root 2. And on the denominator, root 2 times root 2 would be the square root of 4, which is just 2. So you've got 2. And remember that root a times root a is equal to a, so root 2 times root 2 is equal to 2. And then we've got 8 lots of root 2 divided by 2. So if you halve 8 lots of root 2, that'll be 4 lots of root 2. So the answer is 4 lots of root 2. And just thinking about it, if you do 8 divided by 2, that's equal to 4. And that's it, we've rationalised the denominator. The denominator here would be 1, so we've rationalised the denominator. Okay, let's look at our next question, question number 21. So question number 21, we've been asked to expand and simplify root 7 minus root 3 all squared. So let's do that. So we're going to square it, so we're going to multiply it by itself. So root 7 minus root 3 multiply by itself, so root 7 subtract root 3. So we've written the bracket out twice. Root 7 times root 7 is root 49, which is just 7. Root 7 times minus root 3. Well, root 7 times root 3 will be root 21, and it's a positive times a negative, so it will be minus root 21. Then we've got minus root 3 times root 7. Well, root 3 times root 7 is 21. A negative times a positive is a negative, so it's going to be minus root 21 again. And then finally, minus root 3 times minus root 3. Well, negative times a negative is a positive, and root 3 times root 3 is 3. So we've now got 7 minus root 21 minus root 21 plus 3. 7 plus 3 is equal to 10. And then we've got minus 1 lot of root 21 minus another lot of root 21, which would be minus 2 lots of root 21. And that's our answer, 10 minus 2 root 21. And that's it. Okay, let's look at our next question, question number 22. Okay, question number 22, we've been asked to write root 11 plus root 99 in the form of a root b, where a and b are integers. So we just need to work out this addition. So let's simplify these. Now root 11 can't be simplified, so that's root 11. So let's simplify root 99. Now 9 is the biggest square number that's a factor of 99, so root 99 would be equal to root 9 multiplied by root 11. The square root of 9 is 3, so that'll be 3 lots of root 11. So root 99 is 3 root 11. So root 99 is 3 lots of root 11. So if you've got 1 lot of root 11 plus another 3 lots of root 11, that'll be 4 lots of root 11, so 4 root 11. That's our answer, 4 root 11. And that's it. Okay, let's look at our next question, question number 23. Okay, let's have a look at our next question, question number 23. So question number 23, we've been asked to expand 8 subtract root 3 all squared. And we've been asked to give our answer in that form. So we're going to square the brackets. We're going to multiply by itself, 8 minus root 3, and then in brackets 8 minus root 3. 8 times 8 is equal to 64. 8 times minus root 3 would be minus 8 root 3. Minus root 3 times 8 would be another minus 8 root 3. And then finally, minus root 3 times minus root 3. Well, negative times a negative is a positive, so plus. And root 3 times root 3 is 3. Now let's simplify this. 64 plus 3 is 67. And then we've got minus 8 lots of root 3. Take away another 8 lots of root 3 would be minus 16 lots of root 3. And that's it. That's our answer, 67 minus 16 lots of root 3. And that's it. Okay, let's look at our next question, question number 24. So question number 24, we've been asked to show that root 2 plus 3 lots of root 8 all squared is equal to 98. So let's start with the left-hand side here. So we're going to take this bracket and we're going to square it. So that means we're going to multiply by itself. So root 2 plus 3 root 8, then multiply by root 2 plus 3 root 8. Okay, so let's start off with root 2 times root 2. That's equal to 2. Root 2 times 3 root 8. Well, that's 1 root 2. I'll actually just put a plus sign there. That's 1 root 2 times 3 root 8. Well, 1, and I'm saying 1, it's not actually written there, but root 2 would be 1 lot of root 2. 1 times 3 would be 3. And then root 2 times root 8 would be root 16. So that means that root 2 times 3 root 8 would be 3 root 16. And then plus, and we've got 3 root 8 times root 2 again, so that'll be another 3 root 16. And then finally, we've got 3 root 8 times 3 root 8. That'll be plus, and then 3 times 3 is equal to 9. And root 8 times root 8 would be root 64 or just 8. I'm just going to write root 64 for the moment. Okay, so we've multiplied everything together. Root 2 times root 2 is 2. Root 2 times 3 root 8 would be 3 root 16. 3 root 8 times root 2 would be 3 root 16. And 3 root 8 times 3 root 8 would be 9 root 64. Now let's simplify this. So we've got 2 plus 3 times root 16. Well, root 16 is equal to 4. And 3 times 4 is equal to 12. Plus 3 root 16. Well, again, that's going to be 12 because 3 times 4 is equal to 12. And then plus, and then you get 9 times root 64. Root 64 is equal to 8, so we've got 9 times 8, which is 72. So we've now got 2 plus 12 plus 12 plus 72. Well, let's work this out. 72 plus 12 is equal to 84, plus another 12 is 96, plus 2 is 98. So that's it, we've shown it. We've shown that root 2 plus 3 root 8 all squared is equal to 98. Okay, let's look at our next question, question number 24. So question number 25 says the midpoints of the sides of a square of side length 10 centimeters are joined to form another square. So you've got this square, which is side length 10 centimeters. The midpoints are joined together to make this square here. And the process is then repeated to create a shaded square. So that means the midpoints of that square joined together to make another square. And we've been asked to find the area of the shaded square. So we want to find the area of that square. Okay, so let's start off by looking at this triangle here. So we know that that's the midpoint of that side. So if the whole length is 10 centimeters, this would be 5 centimeters here. And then this part would be 5 centimeters as well. And that's a right angle triangle because this is square, that's a right angle triangle. So let's use Pythagoras' theorem. If we use Pythagoras' theorem, we can work out the length of this side here. So from D to this point here. So let's call these sides A, B, and C, C being the whole length here. So Pythagoras' theorem is A squared plus B squared equals C squared. So the two shorter sides, they're the A and the B's, that's 5 squared plus 5 squared, so 5 squared plus 5 squared is equal to C squared, and C is the hypotenuse, so C squared. 5 squared is equal to 25, so we've got 25 plus 25 is equal to C squared. 25 plus 25 is 50, so we've got the 50 is equal to C squared. I'm just going to turn that around to get C squared is equal to 50. And now let's square root, so C is equal to the square root of 50. So it means the length of this side here, this whole side from here to here, is the square root of 50. So that's the square root of 50 from there to there. Okay, so we now know that that length is the square root of 50. And because this is a square, that means that that's root 50, that's root 50, and that's root 50. So what I'm now going to do is I'm going to look at this little triangle up here because these triangles are congruent. They're all the same, these triangles here. So that means that that's a right angle triangle because remember it's just square. And if the whole length of this side from D to C is root 50, that means that from E to C would be half of that. So that means that from here to here would be root 50 divided by 2, or root 50 over 2. And that would be root 50 over 2 as well, because if the whole side is root 50 and we divide it by 2, that's going to be the length of this part here from here to here, the midpoint. So now let's use Pythagoras' theorem again to find the side length of the shaded square, so from here to here. So we've got the two shorter sides, let's label them A and B, and the longer side opposite the right angle will be C. So A squared plus B squared equals C squared. So A squared, that's going to be root 50 over 2 squared. And then plus B squared, that's going to be root 50 over 2, so root 50 over 2 squared. And that's equal to C squared. So let's square this. So we've got root 50 over 2 times root 50 over 2. So root 50 squared would be 50. And then 2 squared would be 4. When you square a fraction, you can just square the numerator and square the denominator. So root 50 times root 50 is 50, and 2 squared is 4. And then plus, and then you're going to get the same here. So 50 over 4, because root 50 times root 50 is 50, and 2 times 2 is 4. And that's equal to C squared. Okay, now let's add these together. 50 quarters plus 50 quarters would be 100 quarters, and that's equal to C squared. Okay, so now let's turn this around. So we've got C squared equals 100 over 4. Now we don't want the squared, so let's square root. So C would be equal to the square root of 100 over 4. Now 100 divided by 4 is 25, so C is equal to the square root of 25, which is 5. So from here to here is 5 centimeters. So that means this square, the side lengths are 5 centimeters each. That's 5 centimeters, that's 5 centimeters, that's 5 centimeters, that's 5 centimeters. Now we've been asked to find the area of the shaded square. So we just need to do 5 times 5, and 5 times 5 is equal to 25 centimeters squared. So the area of that square is 25 centimeters squared. And that's it. Okay, so let's have a look at our next question, question number 26. So in question number 26, we've been asked to simplify root 80, subtract 10 over root 5. So here we've got root 80, that's straightforward, we can simplify that, just simplifying that third. Here we have got 10 over root 5, now we're going to need to rationalise the denominator of this bit here, okay? So let's start off with the root 80. Now in terms of root 80, if we want to simplify this, let's find the biggest square number that's a factor of 80. So 64, no. 49, no. 36, no. 25, no. 16, yes. So that would be root 16, so root 16 multiplied by root 5. And the square root of 16 is equal to 4, so that would be 4 root 5. So that means that root 80 is 4 root 5. So here we've got 4 root 5. Subtract. Now here we've got 10 over root 5. We need to rationalise the denominator of this, so 10 over root 5. So we're going to rationalise the denominator by multiplying both the numerator and the denominator of this fraction by root 5. So multiplying the numerator by root 5 and multiplying the denominator by root 5. So when we multiply the numerator by root 5, 10 times root 5 would be 10 lots of root 5. And then in terms of the denominator, we've got root 5 times root 5, well, that's equal to 5. And then finally, we've got 10 lots of root 5 divided by 5, well, that'll be 2 lots of root 5. and 10 divided by 5 is 2. So that'll be 2 root 5. So that means that 10 over root 5 is equal to 2 root 5. So here, this part will be 2 root 5. So we've now got 4 lots of root 5, take away 2 lots of root 5, and that'll be equal to 2 lots of root 5. And that's it, so that's our answer, 2 root 5. And that's it. Okay, let's look at our next question, question number 27. So the question says, given that 10 subtract root 32 over root 2 is equal to a plus b lots of root 2, find, where a and b are integers, find the values of a and b. So we need to find the values of a and b. So let's start off with this left-hand side. We've got 10 subtract root 32 all over root 2. Now I'm going to simplify this root 32. So let's simplify root 32. So I'm just going to do that here. Root 32 will be equal to, well, let's find the biggest square number that's a factor of 32. 25, no. 16, yes. So root 16 multiplied by root 2. And the square root of 16 is 4, so 4 root 2. So that means that root 32 is equal to 4 lots of root 2. So this would become 10 subtract 4 lots of root 2 over root 2. Okay, now we've got this. We've got 10 subtract 4 lots of root 2 over root 2. Now, here we've got a surd on the denominator. So this is a rational. So let's rationalise the denominator. Let's multiply both the numerator and the denominator by root 2. So in terms of the denominator, that's quite straightforward. Root 2 times root 2 is just 2. So that's the denominator. In terms of the numerator, let's multiply both of these by root 2. 10 times root 2 will be 10 lots of root 2. And then we've got subtract. And then we've got 4 root 2 times root 2. We're just multiplying both of these by root 2. So 4 root 2 times root 2. Well, root 2 times root 2 is equal to 2. But we've got 4 lots of that. So 4 lots of 2 would be 8. So it's going to be subtract 8. So we're almost there. We've now got 10 root 2 subtract 8 over 2. So now we need to divide both of these by 2. Well, half of 10 root 2 subtract 8 would be 5 lots of root 2 subtract 4. And that's it. Now actually, if we have a look at what we're trying to get, actually if we turn this around, we've got our a here and then our plus b lots of root 2. So let's bring that minus 4 to the front. So it'll be minus 4 plus minus 4 plus 5 lots of root 2. Because we've got minus 4 and then 5 lots of root 2 was positive, so it's plus 5 root 2. So the value of a is minus 4 and the value of b is 5. And that's it. So let's write that down. A is equal to negative 4 and b is equal to 5. And that's it. Okay, let's look at our next question, question number 28. So question number 28 says a shed has got dimensions in meters of, the height is root 5 meters, the width is root 6 meters, and the length of the shed is 9 over root 2 meters. And we've been asked to find the volume of the shed. Now I'm going to go back to this question and add in the fact that the shed is a cuboid, and I'll add that in on the practice questions. And it says, give your answer in the form of a root 15, where a is an integer. So given the shed is a cuboid, which I'll add into the question, we need to find its volume. And the volume of a cuboid is the length times the width times the height, or the height times the width times the length, whatever, as long as you're multiplying the 3 dimensions together. So we're going to do root 5 multiplied by root 6 multiplied by 9 over root 2, just multiplying those together. So let's do that. Root 5 times root 6 would be root 30. And then we've still got times by 9 over root 2, just multiplying the first 2 together. Now we're going to multiply these. Well, because we've got a denominator here, I'm just going to put over 1. And let's multiply the numerators and multiply the denominators. Well, root 30 times 9 would be 9 lots of root 30. And then on the denominator, we've got 1 times root 2, which would be just root 2. So we're almost there. We've got 9 lots of root 30 divided by root 2. So let's just divide the surds. Root 30 divided by root 2 would be root 15. So that would be equal to 9 lots of root 15. And that's it. And we just divided the root 30 by root 2 to get root 15. So the volume of the shed is 9 root 15 meters cubed. And that's it. So we were asked to give our answer in the form of a root 15. Well, that'll be 9 root 15. And that's it. Okay, let's look at our next question, question number 29. So question number 29a says simplify root 2y plus root 2y plus root 2y. So here we're just collecting our like terms. If we had 3y plus 3y plus 3y, we'd have 9y, just adding the 3's together. So we just need to add together the root 2, the root 2, and the root 2. Now, root 2 plus root 2 would be 2 lots of root 2, plus another root 2 would be 3 lots of root 2. So root 2 plus root 2 plus root 2 is 3 lots of root 2. And then we've got our y. So the answer would be 3 lots of root 2 y. And that's it. That's what root 2y plus root 2y plus root 2y would be. Okay, now let's look at part B. Part B, we've been asked to simplify fully root 2y multiplied by root 2y multiplied by root 2y. So here, for instance, if we had 3y times 3y times 3y, we would do 3 times 3 times 3 is 27, and y times y times y is y cubed. So here we've got the y times y times y, so we know it's going to be y cubed. But let's find out what goes in front of it. So we need to do root 2 times root 2, which would be 2, because remember that root a times root a is equal to a, so root 2 times root 2 would be 2, times another root 2 would be 2 root 2, so 2 root 2. Or another way to think of it is you've got root 2 times root 2 times root 2, which would be root 8, doing 2 times 2 times 2, and then if you simplify root 8, you get 2 lots of root 2. So the answer would be 2 root 2 y cubed, and that's it. That's what root 2y times root 2y times root 2y would be. Okay, let's look at our next question, question number 30. Okay, so question number 30, we've been told that c is equal to 9 over 2 root y, and then we've got d is equal to 4 over root y, and we've been asked to work out cd, that's c multiplied by d. So we need to multiply these together. So if we do 9 over 2 root y multiplied by 4 over root y, and let's see what we get. So the numerators are really easy. Remember, to multiply fractions, you just multiply the numerators and multiply the denominators. 9 times 4 would be 36. And then in terms of the denominator, we've got 2 root y times root y. Root y times root y would just be y, because remember, y times y is y squared, and then if you square root it, you get just y. And then we've got 2, so it'd just be 2y, because root y times root y is y, multiplied by 2 would be 2y. Now we're almost there. Let's simplify this. We've got 36 over 2y. We can divide both the numerator and the denominator by 2 to leave us with 18 over y. And that's it. That's our answer, 18 over y. Okay, let's look at our next question, question number 31. So question number 31 says that y is equal to 4 lots of root 10 over 5. And we've been asked to work out the value of y cubed. So this is y, so let's find the value of y cubed. So to cube something, you multiply by itself and by itself again. So that would be 4 root 10 over 5, multiplied by 4 root 10 over 5, multiplied by 4 root 10 over 5. Okay, so let's just work this out. So in terms of the denominator, that's quite straightforward. 5 times 5 is 25, multiplied by 5 is 125. So that's the denominator. In terms of the numerator, 4 times 4 times 4 is equal to 64, so 64. And then we've got root 10 times root 10 times root 10. Root 10 times root 10 would be root 100, times root 10 would be root 1000, just multiplying the numbers under the square root symbols. So 10 times 10 times 10 is 1000. Okay, now let's simplify this, because root 1000 can be simplified. Root 1000 would be equal to, well, the biggest square number that's a factor of 1000 would be 100, so it'd be root 100 multiplied by root 10. The square root of 100 is 10, so it'd be 10 root 10. So that means that root 1000 would be 10 lots of root 10. So here we've got 64 times root 1000. So let's replace this root 1000 with 10 root 10. So we've got 64 multiplied by 10 lots of root 10, all over 125. Okay, now let's simplify this. So in terms of the numerator, 64 times 10 lots of root 10 would be 640 lots of root 10. Just doing 64 times 10, and then putting the root 10 after it, over 125. And now finally, we just need to cancel this down. So we're going to look at these numbers, the 640 and the 125, and we're going to cancel down that fraction. So I'm actually just going to cancel it down here. So if we had 64 over 125, let's cancel that down. Both of those numbers are divisible by 5. In terms of 125, well, we know that 5 times 5 times 5 is 125. So if we divide by 5, that'd be 25. Okay, now let's divide the numerator by 5. So if we take our 640, and divide that by 5, let's see what we get. So how many 5s go into 6? That'd be 1, remainder 1. How many 5s go into 14? That's 2, remainder 4. And how many 5s go into 40? That's 8. So that'd be 128. Now in terms of 128 and 25, now, so the factors of 25 are 1, 5 and 25. Well, 128 is not divisible by 25 or 5, so that means that this can't be simplified any further. So now, we had 640 root 10 over 125. If we cancel down this fraction, we get 128 over 25. So it'll be 128 lots of root 10 over 25. And that's our answer, 128 root 10 over 25. And that's the value of y cubed. Okay, let's look at our next question, question number 32. So question number 32, we're told that 3 plus c lots of root 5 all squared is equal to d plus 24 lots of root 5. And we've been asked to work out the values of c and d. Okay, so what I'm going to do is I'm going to expand these brackets and see what we get. So we've got 3 plus c root 5, and then brackets, and then because we're squaring it, we're multiplying it by itself, 3 plus c root 5. Okay, so let's expand these brackets and see what we get. So 3 times 3 is equal to 9, so that's 3 times 3. 3 times c root 5 would be equal to plus 3c root 5, because you just do 3 times whatever value this is, so that'll be 3c root 5, plus, then we've got c root 5 times 3, so that'll be another 3c root 5, because again you do 3 times c and then have the root 5 after it. And then finally, plus, we'd have c root 5 times c root 5. Well, c times c is c squared, and then root 5 times root 5 is equal to 5, so that'll be 5c squared, just putting the 5 in front of the c squared. Okay, so we've now expanded our brackets. Now we know that this is equal to d plus 24 root 5, just putting that right hand side there. Okay, and also we can simplify this. We can do 3c root 5 plus 3c root 5 would be 6c root 5. So that would be 9 plus 6c root 5 plus 5c squared is equal to d plus 24 root 5. Okay, so what I'm actually going to do is I'm going to focus on these root 5s. So on the left hand side we've got 6c root 5, on the right hand side we've got 24 root 5. Now the number of root 5s on the left hand side would have to be equal to the number of root 5s on the right hand side. So that means that 6c has to be equal to 24. So let's write that down. 6c equals 24. Now if we solve this, we can divide both sides of the equation by 6 and we get that c is equal to 4. And let's just check that. 6 times 4 is equal to 24, so we'd have 24 root 5 here and 24 root 5 there. Now this is fantastic. We now know that c is equal to 4. So that means that we can work out what d is. That's the other thing we need to work out. Because on the left hand side, we've got, in terms of our numbers that don't involve our root 5s, we've got 9 and then we've got 5c squared. On the right hand side, that's equal to d. So if we work out what 9 plus 5c squared is, that'll be what d would have to be. So let's do that. So we'd have 9 plus, and then we've got 5c squared is equal to d. So that term plus that term has to be equal to that term, because the terms with root 5s have to be equal to each other. And then these two would have to add together to be that. So now we know that c is equal to 4. So 4 squared is 16 times 5 is equal to 80. So we'd have 9 plus 80 is equal to d. Just remembering to square first before multiplying by 5. But like pi r squared, you square the radius before times it by pi. And then 9 plus 80 is equal to 89. So we'd have 89 equals d. So we've got the c is equal to 4 and d is equal to 89. So c is equal to 4 and d is equal to 89. And that's it. Okay, let's have a look at our next question, question number 33. So question number 33 says that root 300 subtract 2 lots of root x is equal to 4 lots of root 3. And we've been asked to find the value of x. Okay, so the first thing I'm going to do is I'm going to actually, in this question, there's a few different things I could do. I'm going to actually simplify this root 300 to begin with. So root 300 would be equal to root 100 multiplied by root 3, because 100 is the biggest square number that's a factor of 300. And the square root of 100 is 10, so it'll be 10 root 3. So we're going to replace the root 300 with 10 root 3. So we'd have 10 root 3 subtract 2 root x equals 4 root 3. Okay, so we've now got this. Now, in terms of this, whenever I'm looking at something like this, what I'm tempted to do is actually bring all the terms of x's to one side and everything else to the other side. So I'm actually going to add 2 root x to both sides here. So I'm going to add 2 root x to the left-hand side, and I'm going to add 2 root x to the right-hand side. And the reason I'm going to do that is because on the left-hand side, I'd have 10 root 3, and on the right hand side we'd have 4 root 3 plus 2 root x. Now I'm going to subtract 4 lots of root 3 from both sides. That'll then obviously mean that on this side, if we take away 4 lots of root 3 and take away 4 lots of root 3, on the left hand side we had 10 lots of root 3. We're taking away 4 lots of root 3, so that'll leave us with 6 lots of root 3, and on the right hand side we're left with 2 root x. Okay, so we're nearly there. So here we've got the 6 root 3 is equal to 2 root x. Now we want to find out what x is, so the first thing I'm going to do is actually here is I'm going to divide both sides of the equation by 2 to get rid of that 2 there. So I'm going to divide the left hand side by 2 and divide the right hand side by 2. We had 6 lots of root 3, we're halving it, so that'll be 3 lots of root 3. And on the right hand side of the equation, we're dividing by 2 to get rid of that 2, so we'd just be left with root x. So we've now got, I'm going to go back up here, we've got root x is equal to 3 root 3. So just bringing that up there, and I've turned it around as well. Now we want to find out what x is. Now here we've looked in this video at simplifying surds. This is a simplified surd. We have got 3 lots of root 3. It would be handy to know what surd would we have simplified to get 3 lots of root 3. So we're going to go backwards. Remember, whenever we're simplifying for surds, we look for the biggest factor that's a square number, and then we see what else it'd be, and then we square root that square number. So in this question, if we have a look here, we've got 3. So that means that we must have had a root 9, because the square root of 9 is equal to 3. So instead of writing 3, I'm going to write the square root of 9. And then that would still be multiplied by the square root of 3, because if we had this, we would square root that to get 3 root 3. Now we've got root a times root b, we can just times them together. 9 times 3 is equal to 27. So we've now got the square root of x is equal to the square root of 27. So just going backwards, we have our simplified surd. We are unsimplifying it. So you're squaring this to find what's going to go underneath the square root symbol. And then you're going to times these two together to give us the 27. So we've now got the square root of x is equal to square root of 27. So x has to be equal to 27. And that's it. So x is 27. Okay, let's look at our next question, question number 34. So question number 34 says that given that the square root of 1 and 2 25ths plus the square root of 12 is equal to a root 3 over b. And we've been asked to work out the values of a and b. Okay, so let's focus on this left-hand side and see what we get. So we've got the square root of 1 and 2 25ths. Now I'm going to make this a top-heavy fraction. If we've got 1 and 2 25ths, if we do 1 times 25, that's 25, and add on the extra 2, that's 27. So that'll be 27 25ths. And we've got the square root of that plus the square root of 12. Now actually with the square root of 12, I'm going to simplify it because here we've got root 3. So let's simplify root 12. Root 12, the biggest square number that's a factor of 12 is 4. So that'd be root 4 times root 3. And the square root of 4 is 2, so that's 2 root 3. So the square root of 12 is equal to 2 times the square root of 3. So that's 2 root 3. Okay, so now let's focus on this, because remember that if we have root a divided by root b, that's equal to root a over b. So I'm going to split this up. So instead of being the square root of 27 over 25, I'm going to write the square root of 27 over, that's another word for writing divided by, the square root of 25 plus 2 root 3. So we've just split this up into the square root of 27 over the square root of 25. Now the square root of 25 is 5, so that'll be root 27 over 5 plus 2 root 3. So we're getting there. Now here we've got root 27. Let's simplify root 27. So root 27 would be equal to, the biggest square number that's a factor of 27 is 9, so that'll be root 9 times root 3. And the square root of 9 is 3, so that's 3 root 3. So that means that here we've got, instead of root 27, I'm going to write 3 root 3 over 5. Plus 2 root 3. So we're almost there. We've got our root 3's here and here. But here you can see this has been written as just one fraction. So we need to add these together. So here we've got 3 root 3 over 5. Now we could write 3 root 3 over 5 in a slightly different way. We could actually bring it the 3/5 in front of the root 3. So that'd be equal to 3/5. Just writing it in a slightly different way. So this would be equal to, here, if we just go up here to here, we would have 3/5 root 3 plus 2 root 3. So if we add these together, we'll get what our answer is. So let's add together the 3/5 and 2. Well, 3/5 plus 2 would be 2 and 3/5, so it'd be 2 and 3/5. Or as a top-heavy fraction, 2 times 5 is 10, plus 3 is 13, 13/5. So that means that here, if we add these together, we get that would be 13/5 root 3, or we could put the root 3 back on the numerator to get 13 root 3 over 5. And that's in that form. And we've been asked to work out the values of a and b, so a is equal to 13 and b is equal to 5. And that's it. Now in this question, actually I want to go back to this point here, adding these two together. We could actually have just made the denominator 1 there and found equivalent fractions. So we just multiply both the numerator and denominator of this fraction by 5. That would give us 10 root 3 over 5. And then you'd add together the 10 root 3 and the 3 root 3, and that would be 13 root 3 over 5. So actually, with hindsight, that's probably how I would have approached that. So here, I would have times both of these by 5 to get 3 root 3 over 5. plus, and then times both of those by 5 would be 10 root 3 over 5. And then adding them together would be 13 root 3 over 5. And you can see that A is equal to 13 and B is equal to 5. Okay, let's look at our next question, question number 35. Okay, so question number 35, we've been asked to write 4 over root 5, subtract the square root of 2 and 2/9 in the form of a root 5. So let's work this out. So we've got 4 over root 5, so I'm going to multiply both the numerator and denominator of this by root 5. So if we had 4 over root 5, we can times both the numerator and denominator by root 5. We're rationalising the denominator. So 4 times root 5 is 4 root 5, and root 5 times root 5 is 5. So that means that this 4 over root 5 will be equal to 4 root 5 over 5. So that would be 4 root 5 over 5. Then we've got our takeaway, and then we've got this, our square root of 2 and 2/9. Well, let's make this a top-heavy fraction. 2 times 9 is 18, plus 2 is 20, so that'll be 20/9, and it's the square root of 20/9. Now let's split this up. Remember, if you've got the square root of a fraction, you can just do the square root of the numerator over the square root of the denominator. So here we would have 4 root 5 over 5, subtract root 20 over root 9. Just splitting that up. The square root of 9 is 3, so we've got 4 root 5 over 5, subtract, and then we've got root 20 over 3. Okay, now let's look at this root 20 because we want it in the form of a root 5, so we don't want root 20s in our answer. So root 20, let's simplify it. The biggest square number that's a factor of 20 is 4, so that'll be root 4 times root 5. And the square root of 4 is 2, so that's 2 root 5. So root 20 is 2 root 5. So here, I'm just going to go up here now. So we would have 4 root 5 over 5, subtract 2 root 5 over 3. Now we want to write it in the form of a root 5, so let's work this out. So we've got, let's get a common denominator. So I'm thinking 15, so over 15 minus over 15. So to get from 5 to 15, we times by 3, so let's multiply the numerator by 3. So if we've got 4 lots of root 5 and we times it by 3, we'd have 12 lots of root 5. And then here to get from 3 to 15, we times by 5, so let's multiply the numerator by 5, so that'll be equal to 10 root 5. And then finally, we've got 12 root 5 over 15, subtract 10 root 5 over 15. Well, they've both got the common denominator of 15. And then in terms of the numerator, 12 lots of root 5, take away 10 lots of root 5 will be 2 lots of root 5. Now we're asked to write it in the form of a root 5. So here, I'm just going to put the 2/15 in front of the root 5. So it'll be 2/15 root 5. And that's it. Okay, let's look at our next question, question number 36. So question number 36, we've been asked to write 6 over 1 over root 2 plus root 2 in the form of a root 2. So what I'm going to do is I'm going to focus on this denominator to begin with. Actually, I'm going to focus on this part first of all, the 1 over root 2. So 1 over root 2. Let's rationalise the denominator by multiplying both the numerator and the denominator by root 2. So times by root 2 and times by root 2. So that would give us 1 times root 2 is root 2, and root 2 times root 2 is 2. So 1 over root 2 is equal to root 2 over 2. So that would become, I'm just going to focus on the denominator at the minute. So the denominator would be, we'd have root 2 over 2 plus root 2. So here we're going to add these together. I'm just going to put that over 1, and let's get a common denominator of 2. So let's double both of the numerator and denominator here. So it'll be root 2 over 2 plus 2 root 2 over 2. Just doubling both the numerator and denominator. And then if we add these two together, root 2 plus 2 lots of root 2 would be 3 lots of root 2 over 2. So we're almost there. This is our denominator. So we've now got 6 over this. Now I could write 6 over 3 root 2 over 2, but I'm actually going to write it in a slightly different way. I'm actually going to write it with a divide by symbol. So I'm going to write 6 divided by this 3 root 2 over 2, because remember the line means divided by, and the denominator is equal to 3 root 2 over 2, so we've got 6 divided by 3 root 2 over 2. So here we've got 6, so I'm going to write 6, and instead of divide we're going to multiply by the reciprocal, so 2 over 3 root 2, and I'm going to put it as 6 over 1. And now we just need to times them together. 6 times 2 is equal to 12, and in terms of the denominator, 1 times 3 root 2 would be 3 root 2. And we're almost there. And now we're almost there. Actually, one thing I've noticed is that we can actually do the 12 divided by 3. 12 divided by 3 is 4, so that would be, instead of 12 over 3 root 2, we could write 4 in the numerator, and then it would just be root 2 in the denominator. I'd divide both the numerator and denominator of that fraction by 3, and that would leave us with 4 over root 2. And now finally, we want to write it in the form of a root 2, so let's multiply both the numerator and denominator by root 2. We're rationalising again. So in terms of the numerator, 4 times root 2 is 4 root 2. And in terms of the denominator, root 2 times root 2 is 2. And actually, there's one more thing we can do. 4 lots of root 2 divided by 2 would be 2 lots of root 2. And that's our answer. So a is equal to 2. After all that, we've just got an answer of 2 root 2. Okay, let's look at our next question, question number 37. Okay, so question number 37, we've been asked to show that 16 over root 11 subtract 3 can be written in this form. So we need to rationalise the denominator. This denominator is irrational because this is an irrational number, and if you take away 3, it'll still be irrational. So we need to rationalise the denominator here. Now this is a little bit different than the ones we've looked at so far, because the ones we've had so far have just been, for instance, the denominator of root 3 or root 7 or something like that. Here we've got root 11 subtract 3. Now what we're going to do is we're going to take that fraction, our 16 over root 11 subtract 3, and to get rid of the surds on the denominator, what we do is we multiply by the conjugate of root 11 subtract 3. And that sounds complicated, but it's the same thing, but just change the sign. So we're going to multiply both the numerator and denominator of the fraction by root 11 plus 3. So we're going to times by root 11 plus 3 and root 11 plus 3. So just multiplying both the numerator and denominator by the conjugate of the denominator. In other words, the same thing as the denominator, but you just change the sign. If that's a minus, you make it a plus. If it's a plus, you make it a minus. So the numerator is quite straightforward. We just need to multiply both of these by 16. So 16 times root 11 would be 16 root 11, and 16 times 3 would be plus 48. So that's the numerator. In terms of the denominator, we need to multiply these together. And I'm just going to put these in brackets, because here we've got 2 brackets times together, and we need to expand them. So let's expand our brackets. Actually, I'm just going to do it down here. So we've got root 11 subtract 3 multiplied by root 11 plus 3. So root 11 times root 11 is equal to 11. Root 11 times 3 would be plus 3 root 11. Minus 3 times root 11 would be minus 3 root 11. And finally, minus 3 times 3 would be minus 9, so minus 9. Now here, the great thing about this is you'll see here that these cancel out. If you've got 3 root 11, take away 3 root 11, they will cancel out. And then we've got 11, take away 9. And 11 take away 9 is 2. So the denominator just becomes 2. And that's fantastic, and we have rationalised the denominator. So we're almost there. We want it in this form. So we now need to divide by 2. So we can actually divide both of these by 2. This is quite nice, this question. So if we divide both of these by 2, 16 lots of root 11 divided by 2 would be 8 lots of root 11. And then we have plus 48, but we're dividing by 2, so it'll be plus 24. And we're almost there, because if we look here, we want it in the form of a plus b root 11. So let's turn this around to be 24 plus 8 root 11. And that's it. So a is equal to 24 and b is equal to 8. And that's it. So we've rationalised the denominator, and we've got our answer of 24 plus 8 root 11. So let's write that down. 24 plus 8 root 11. Okay, let's look at our next question, question number 38. So question number 38 is a similar type of question where we've been asked to rationalise the denominator. Here we can see the denominators are rational. If you do 2 take away the square root of 3, that'll be irrational. So we need to multiply both the numerator and the denominator of that fraction by 2 plus root 3. We're going to times both the numerator and denominator by the conjugate of the denominator. So we had 6 over 2 subtract root 3. We're going to multiply both the numerator and denominator by 2 plus, so brackets 2 plus the square root of 3, 2 plus the square root of 3. Okay, so in terms of the numerator, we've got 6 times this bracket, so 6 times 2 is equal to 12, and 6 times root 3 would be plus 6 root 3. Then in terms of the denominator, we need to times these together. I'm going to put that in brackets. So we've got 2 minus root 3 times 2 plus root 3. 2 times 2 is 4. 2 times root 3 would be plus 2 root 3. Minus root 3 times 2 would be minus 2 root 3. And finally, minus root 3 times root 3 would be minus, and then root 3 times root 3 is 3. And then if we have a look here, 2 root 3, take away 2 root 3, cancel out. And 4, take away 3 is equal to 1, so the denominator just becomes 1. And that's quite nice because we now just need to divide this by 1, so it's going to be 12 plus 6 root 3. And that's it, we're done. 12 plus 6 root 3. And that's it. Okay, let's look at our next question, question number 39. Okay, so question number 39 says to write 4 root 2 over 3 plus root 2 plus 6 over root 2 in this form here. Okay, so let's do that. Now, actually, if we have a look here, we've actually got two fractions where both the denominators are rational. So I'm going to rationalize the denominator of both of them to begin with. So let's start off with the 6 over root 2. That's quite nice. 6 over root 2. We can multiply both the numerator and denominator by root 2. And that would give us 6 times root 2 is 6 root 2, and root 2 times root 2 is 2, and 6 root 2 divided by 2 would be 3 root 2. So this is 3 root 2. So that's quite nice. Now, in terms of this fraction, here we've got 3 plus root 2, so we're going to need to multiply both the numerator and the denominator by the conjugate of the denominator. In other words, it's going to be 3 minus root 2. So we'll have 4 root 2 over 3 plus root 2. So I'm just focusing on this now. We're going to multiply both the numerator and denominator by the conjugate of the denominator, so it'll be 3 minus root 2. 3 minus root 2. Just close the brackets there. Okay, so let's do that. So in terms of the numerator, 4 root 2 times 3 would be 12 root 2, so 12 root 2. Then we've got our minus, and then we've got 4 root 2 times root 2. Root 2 times root 2 is 2, and then times by 4 would be 8. So that's our numerator. And then in terms of the denominator, let's work out what this would be. 3 times 3 would be equal to 9. 3 times minus root 2 would be minus 3 root 2. Root 2 times 3 would be plus 3 root 2. And then we've got root 2 times minus root 2 would be minus, and then root 2 times root 2 is 2. These cancel out, so we're left with 9, take away 2, which is 7. So it's going to be 7. So we know that this is equal to 12 root 2 subtract 8 over 7, and this is equal to 3 root 2. Okay, so let's write that down. Where am I going to do that? Let's do it here. So we've got 12 root 2 minus 8 over 7 plus 3 root 2. Okay, now we want to simplify this, so let's add them together. We're going to make a denominator of 1 here, and let's multiply both the numerator and denominator of this fraction by 7. So that will give us, so multiplying the numerator by 7 will be 21 root 2, and multiplying the denominator by 7 will be 7. And then let's add together here. 12 root 2 plus 21 root 2 would be 33 root 2, 33 root 2. And then we've still got our minus 8, and that's going to be all over 7. So that's it. Actually, if we have a look here, our a is equal to 33. We've got our minus b, so we've got our minus 8 there, and then we've got our 7 on the denominator, and that's it. So we've written it in that form. Okay, let's have a look at our last question, question number 40. So question number 40, we've been asked to write root 2 subtract 2 all over 3 root 2 plus 4 in this form. Okay, so let's have a look at this. We need to rationalize the denominator, and to rationalize the denominator, we're going to multiply both the numerator and the denominator by the conjugate of the denominator. In other words, this, but instead of a plus sign, we have a minus sign. So let's do that. So in terms of the numerator, we've got root 2 subtract 2, and we've got our denominator, 3 root 2 plus 4, and we're going to multiply both the numerator and denominator by the conjugate of this, so it's going to be 3 root 2 minus 4 and 3 root 2 minus 4. Okay, so let's do that. So in terms of this, let's put them in brackets and see what we get. So I'm going to do the expansion. I'm going to write the answer up here, but I'm going to do the expansions down here. So let's focus on the numerator. We've got root 2 minus 2, and then we've got 3 root 2 minus 4. So let's work out what this would be if we expanded it. So root 2 times 3 root 2, well, root 2 times root 2 is 2, and times by 3 would be 6, so we've got 6. And then we've got root 2 times minus 4, so it's going to be minus 4 root 2. Then we've got minus 2 times 3 root 2, so that'd be minus 6 root 2, so minus 6 root 2. And then we've got minus 2 times minus 4, so it's going to be plus 8. Then if we simplify this, 6 plus 8 is 14. And then we've got minus 4 lots of root 2, take away another 6 lots of root 2, would be minus 10 root 2. So that's our numerator, 14 minus 10 root 2. Okay, now let's have a look at the denominator, and hopefully whenever we expand these, we're going to get something that's rational. So let's do that. So we've got brackets 3 root 2 plus 4, and then in brackets 3 root 2 minus 4. Okay, so let's expand them. 3 root 2 times 3 root 2. Root 2 times root 2 is 2. And then 3 times 3 is 9. 9 times 2 would be equal to 18. Then we've got 3 root 2 times minus 4, so it'd be minus. And then 3 times 4 is 12. And then we've got our root 2. Now we've got 4 times 3 root 2. Well, 4 times 3 is 12. Root 2, so plus 12 root 2. You can see they're going to cancel out. And then 4 times minus 4 would be minus and then 16. So this is great. They cancel out. We've got 18 to take away 16, which is equal to 2. So the denominator is 2. Now we just need to divide by 2 here. So if we divide the numerator by 2, we get that's equal to 7, because 14 divided by 2 is 7. And then minus, and 10 root 2 divided by 2 would be 5 root 2. So that's it. 7 minus 5 root 2. And that's it. So let's write that down. And that's it. So in this video, we've gone through the video solutions to the Corbettmaths practice questions on Surds. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. If you need any extra help on Surds, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 305, 306, 307 and 308, there's dedicated video tutorials that are really useful for Surds. But again, I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.